Okay, now I want you to compare that cycle very quickly to the diesel cycle. You guys are responsible for diesel, right? But I want to show you what it would look like. So for a diesel cycle, it actually also has four different steps, but they are slightly different. So the first step is the same, adiabatic compression. Step 2 to 3 is actually a constant pressure step. And step 3 is adiabatic expansion. And this is constant volume step. So this step is different. This is where Q in is taken. So that means fuel is taken in and compressed. Whereas this is where spark happens. So there is a picture in the book. Yeah, so this is for actually the internal combustion engine, right? So this is step 1, step 2, so this is actually showing a 4-stroke engine in all 4 steps. Yeah. Okay, anyway, so you guys will be explaining about the diesel engine, right? So I don't have to worry about it. Excellent. But I will still like you guys to see what the graph would look like. So first step, if I keep the same P and B, so call this V1, call this V4, what will it look like? The first one is an adiabatic compression. So from step 1, that will look the same. What's the difference now? Step 2 will be different because that will look like this. Step 3 will be that, and step 4 will be that. Do you see the time difference between these 2 cycles? In this cycle, Q in is here, Q out is there. What's the difference between these? What? Look at workout. What do you observe?
It's less than.
Yes. So I'm going to try to draw this to the best of my abilities, but note this. This is why I wanted to draw it. Do you see that? The power stroke of an internal combustion engine is longer than that for the diesel. Well, look at this. That's the power stroke, right? Look at this.
It doesn't matter. This is not energy. Work with it.
Yeah.
So internal combustion.
So that is why you don't see race cars with diesel engines. And every time you get a diesel engine, they always do a turbo diesel, right? So they add on to a diesel engine to make it go faster, to speed up quicker.
Is there benefits out of a shorter power cycle?
Not necessarily the power cycle, it's the whole package. So diesel engines are okay. So diesel is more crude. It lasts longer in terms of fuel. It takes longer that's why we don't do ignition in them. We do a compression in them. And also the fact that it's more expensive to make regular fuel than it is to make diesel. Yeah, and then the fuel efficiency is way more. So you will not put your regular petrol in your 18 wheelers, right? Because that will just not be productive enough. Whereas it will last longer, it has better efficiency, it has better everything, except it won't speed up fast enough. Yes, and that's why most of the, I'm not sure about this fact, but I know like for most of the trucks, they prefer them to be manual because then they can control how much they can put in the power at any given time. And the engines last longer, manual. Yeah, that's why you can hear them, right? When they're stopping at a stop sign and they go, grr, 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 and they have what, 16 gears or something? Like ridiculous amount of gears.
Earlier, due to the higher pressure in the ratio. So if you have a early combustion, that wouldn't be good because the distance going up and it's combust going down, which is that's a big drive.
So the higher the output, the more